Good morning. Today we'd like to talk about Lesson 1-6, two-dimensional figures. We'll forget the bell ringer. Well, our first concept in Lesson 1-6 is the definition of a polygon. A polygon, as you can see, is a closed figure formed by a finite number of coplanar segments, such that the sides all have a common endpoint that are non-collinear. Each side intersects exactly two other sides, but only at their endpoints. When we name a polygon, we name it by the letter of its vertices in consecutive order. So as you can see, the three on the left are all polygons. The three on the right are not polygons. This one is not a polygon here because it's not closed. This one's not a polygon because this side is not a segment. Here, the third one's not a polygon because these segments intersect in the middle, not at the endpoint. An important concept we talk about with polygons is the concept of concave or convex. A convex polygon is a polygon such that no line containing a side of the polygon contains a point in the interior of the polygon. If it's not convex, it's concave. I like to think about it this way. Imagine if you took a rubber band and put it around the polygon. If there's no gap where you can put a pen or pencil in between the polygon and the rubber band, it's convex, such as these three. Notice here on the two that are concave, if I took a green rubber band and stuck it around this polygon, I'd have a gap right here that I could put something in between that would be in between the rubber band and the polygon. Therefore, it's concave. Notice the next one. The blue rubber band, we'd have a gap right here where something could go in between. That makes it concave. We classify polygons and name them by the number of its sides. Some of these should be very familiar to you. A three-sided polygon is a triangle. Four sides, quadrilateral. Now there's different types of quadrilaterals, which we'll talk about a lot coming up here this trimester. But any four-sided polygon is a quadrilateral. There's a pentagon with 5 sides, hexagon with 6, heptagon 7, the octagon has 8. You're familiar with an octagon, it's a stop sign. Nonagons have 9, the decagon has 10, and a dodecagon has 12. These are the common names that we use. Anything that goes past 12, we just call it an n-gon. So if you had a polygon with 15 sides, it would be a 15-gon. More on classifying polygons. It's an equilateral polygon if all the sides are congruent, such as a square. In an equiangular polygon, all the angles in the interior of the polygon are congruent, like in a square or a rectangle. Finally, a regular polygon is a convex polygon that is both equilateral and equiangular. Take a look at the example of our regular pentagon here. A square would also be an example of a regular polygon because it's equiangular, all 4 sides are equal, and all four angles are equal because they all equal 90. The other thing that we need you guys to be able to do, well, let's take a look at our skills practice first. Name each polygon by its number of sides and then classify it as convex or concave and regular or irregular. So our first one, you can see, has 4 sides. That makes it a quadrilateral. Notice that it's convex, there's no indents. And finally, not all the sides are congruent, therefore it's irregular. All the angles are congruent, they all equal 90 degrees, but the sides are all not congruent, therefore it's not regular. Our second example, well, it's a triangle because it has 3 sides. It is convex. As a matter of fact, every triangle is convex. You can't make a polygon that's a concave triangle. All the sides and the angles are congruent or equal, therefore it is regular. Finally, our third polygon, it has 5 sides, so therefore it's a pentagon. Notice that we have the gap here where these 2 sides indent in, if you will. That makes it concave. And not all the sides are congruent, therefore it is irregular. The other concept we need you guys to remember is the concept of perimeter and area. The perimeter of a polygon is the sum of the lengths of its sides of the polygon. You simply have to add up all the sides. The circumference is the distance around a circle. It's just like perimeter, except it's for a circle, not a polygon. Notice that to find the circumference, we use the formula 2 pi r. The area is the number of square units needed to cover a surface. Notice that whenever you do area, your units will be squared units. For the square, we take s squared. The rectangle, length times width. Triangle, 1/2 base times height. And the circle, pi r squared. Take a look at our examples. Find the perimeter or circumference of each figure. Round to the nearest tenth. Well, for number 4, well, it's simply a quadrilateral. So to find the perimeter of this figure, we're going to add up all the sides. 20 plus 20 plus 40 plus 18. This perimeter will be 98 yards. In number 5, it's a pentagon, so we have to add together all 5 sides. 2 plus 4 plus 6 plus 3 plus 5. Notice I tend to go around in consecutive order. And it would be 20 meters. Perimeter is a linear unit, so therefore we always just keep the unit as it is. Finally, for number 6, it's a circle, so we're going to use the formula 2 pi r. R, of course, stands for the radius, and the radius of the circle is 11. So it's 2 times pi times 11. That's 22 pi. Sometimes we'll leave the answer in terms of pi. It's the exact value. In this case, they ask us to round to the nearest tenth. So using 3.14 for pi, we get 69.1. Now, depending on what you use for pi, this will change your answer slightly. So make sure you look at the directions for what you're doing. Are you supposed to leave it in terms of pi? Are you supposed to use 3.14? Or are you supposed to use the pi keys on your calculators? Our final 3 examples are area. So notice that this is a rectangle. Length times width. 12 times 5. This is 60 square meters. Again, square, because this means that we would need 60 meters, 60 squares, 1 meter on each side to cover up this entire rectangle. Number 8, of course, is the circle. Its formula is pi r squared. Radius is 7. Remember, we have to do the exponent first, order of operations. So we square the 7, we get 49 pi. And again, using 3.14 for pi, I get 153.9 square centimeters. Finally, in number 9, it's a triangle. A triangle's area is always found by taking 1/2 base times height, where the base is 16, the height is 14. 1/2 of 16 is 8. 8 times 14 is 112. So number 9, the area would be 112 square feet. You should now have an assignment to link to, so please begin work on that.